Hi, I'm going to tell you something this time about a little device I built that gets weather information from Environment Canada. It can do that for any Canadian city or town and displays it on three 7-segment 4-digit LED displays as well as on the Arduino back end. The device is simple. Internally it contains almost nothing. It has an Arduino ESP32 and it has the displays and some LEDs. It also has its own barometer sensor because barometric pressure you can get inside or outside and it's the same value, so I can get that locally. All the rest is from the web. So a simple device means it's going to be reliable and it's, I think, fairly well built in a standard project box. Have a look, this is what it looks like. So now let's have a look at the code. The full code is in the documentation. I just want to point out a few important things. The first section has, well, first of all, the version history. I find that quite useful. Then there's all the declarations, definitions, includes, and so on. Constants for things like the URL that it goes to get its values. The Wi-Fi details, which are secret, so I've made them impossible to read here. XXX is not in fact the password. And then values for low and high, warnings, and so on. A few other things. Trend, which can be down, nil, or up. That's to avoid too many strings. Then there are some strings that I need to communicate with the Arduino cloud. They are defined by Arduino, and all I have to do is assign value to these strings, and those values are then communicated automatically to the Arduino backend. Alright, there's a watchdog defined, there's a local barometer sensor and a local include for the 7-segment displays. When that's all done, I define all the LEDs and so on, and I set some values to nil. That means until I set them they are invalid. You can do that with real numbers, with floating point values. I can set them to something that is just wrong, or to nothing. Alright, then the setup, and that just of course is run once. In the setup, I set the LEDs, I start stuff, I make sure that the barometer works, and if not, I stop because there's no point. I define arrays of all the different numbers because it keeps values for about 5 hours. That's to see trends, to analyze whether things are going up or down. And in the end, I start the watchdog. The watchdog is there in case things halt, then it reboots all by itself. Alright, the loop is fairly simple because the work is done by functions. First there's a section in the loop for every second, and every second it checks if Wi-Fi is connected, and if not, it turns off the green light. It raises an alarm. It does a few other household things, and then every 10 seconds it communicates with Arduino, and it also communicates its free memory to the Arduino backend. That is really just for debugging, that can go. There is no memory leak. And then every 5 minutes, it does the real work. First, it checks its own QNH from its own sensor. Then it gets the web data. That's a function, right? The function get web data, which is defined below. And then there's functions to do the rest, update all the histories, all those arrays, analyze all the trends, are they going up or down, these values, check for warnings, and if there are warnings, act accordingly. And then that's it. That's the whole loop. So most of the work is done by functions. Functions to get the temperature from the Environment Canada XML value, once I've obtained that value, and derive the humidity, derive the wind speed, derive the wind gusts, wind direction. Right. This is the function get web data that actually fetches the information. That's an important one. It's HTTP client, and it is important to have timeouts in there because you don't want the system to hold outside the loop when there's no response, or when the web server doesn't respond, or when it's too slow to respond. And there's both a connect timeout and a timeout. Both of them are important. All right. Then there's some calculations, calculating the dew point, because that's a calculation. All you need to know is the temperature and the humidity, and you can calculate the dew point. And then there's a few display routines, one that displays the normal values, one that displays the alternate values. When I turn switch 2 down, instead of temperature, humidity, and QNH, I see other values. I see wind speed, wind direction, wind gusts. So depending on the switch, I see different things on my red LEDs. There's a routine to connect to Wi-Fi. That's a fairly complicated routine as well, because if the Wi-Fi connection doesn't work, well, we need to signal that. We need to make sure we have the right LEDs on and so on. All right, let's see. That's connecting to Wi-Fi, checking regularly that it's connected, checking for warnings, and that's the most important routine. That is basically the matrix where I compare values and see if I should issue a warning. For example, if it's very cold, or if it's very humid, or if there's a lot of wind, or if there is a strong barometer drop, an extreme QNH drop or a QNH drop, because that probably signals bad weather or wind. Wind gust warnings, and then there's some calculated warnings for car icing possible freezing rain, possible dew, possible snowstorms, another freezing rain, possible warning, calculated a different way, so there's 2 ways to calculate that, possible thunderstorms. And then there's a few other household functions you need. So this very simple project that only gathers a few values from the internet and issues a few warnings depending on those values turns out to be fairly complicated. 900 lines almost of code and comments. So I urge you to look at those and to see if you can do it in less. I'm not sure you can, because doing it and doing it well are 2 different things. And I think this is fairly thorough code. And finally, the Arduino back end. And that's what it's all about, really, isn't it? We have here all the values I gathered: temperature, humidity, air pressure, wind gusts, if any, and wind bearing, and their trends. Null means no change, no significant change. And as you can see, the only one that's changing is wind speed, which is dying down. Top right's the most important field. That's where the warnings, if any, will occur. So that field, when it says nominal, that means there's nothing happening. And it could say something like possible thunderstorms, or possible freezing rain, or possible car icing. All those things would appear right there. Below that, some technical things: uptime, last web response, 200 is correct. Free memory, that's really a debugging value. We don't really need that. And below that, the trend over the past day, or 7 days, or 15 days, or the past hour, in the most important variables: temperature, humidity, and air pressure and wind speed. And those are very interesting to watch. And because it's the end of the year, that is to say the autumn has already started, so it's a depressing thing to watch, because every day the temperature gets lower. Further details are in the notes. Let me know what you think.